Hello everyone. So today is the day 10 of the September LeetCoding challenge, and on this day we have been given to solve this problem, that is arithmetic slices to subsequence. And I have already made a video on this problem for LeetCode dynamic programming playlist, and in couple of seconds you will be able to see that video. So see you guys in on the day 11. So in this problem we have been given an integer array nums, and we need to return the number of all the arithmetic subsequences of the nums. So now what is an arithmetic subsequence? So it has been defined as a sequence of numbers which consist of at least three elements, and if the difference between any two consecutive element is same, then it can be said to be a arithmetic subsequence. So let us take some examples. So for example, this 13579 is an arithmetic subsequence because it has got 5 elements, and the condition, like this criteria, says that there should be at least 3 elements, and the difference between each consecutive element is 2. Similarly, this 7777 is also an arithmetic subsequence because it has got 4 elements, and the difference between the consecutive element is 0 here, and here the difference between the consecutive element is 2. And this is not an arithmetic sequence because here the difference is 0 and here the difference is 1, so the difference is not same. And a subsequence of an array is a sequence that can be formed by removing some elements of the array. So like if there is an array and we are removing some elements out of that array, then the remaining thing can be called a subsequence. So that is a standard definition. Now the problem says one more thing, that the test cases are generated so that the answer fits in 32-bit integer. So basically we need to return the answer in an integer, and they guarantee that the answer will fit in this integer range. So let us take a look at the constraint first. So there are like less than equal to 1000 elements in the nums array, and the elements of the nums array have the ranges of that integer. So seeing the ranges, we can see that if we'll try to add two elements of the nums array, it may result into overflow. So it will be a safer practice to use longs as much as possible in this problem, even though the final answer will be an integer. So we may take an example. So here in this example, there is an array containing the elements 2, 4, 6, 8 and 10, and there are 7 arithmetic subsequences. So one is 2, 4, 6, another is 4, 6, 8, and so on. And there is one more example in which there is an array containing 5, 7. So the answer has been said to be 16. So any subsequence of this array is arithmetic. So any subsequence having length 3 or more will be an arithmetic subsequence, because the difference is always 0. So only criteria we need to fulfill is the minimum length. So the number of subsequences, arithmetic subsequence, will be 5c3 plus 5c4 plus 5c5. So that will be 1 plus 5 plus 10, that is 16. So that is also correct. So now generating the calculating the arithmetic subsequences of length at least 3 would be a tough task. We can do one thing, we can find out the number of all the subsequences of length greater than equal to 2, and we can then subtract all the subsequences of 2 length present in the array. So basically the number of subsequences of length 2 in the array is straightforward, that is nc2, which is n into n minus 1 by 2. So finding the arithmetic subsequences where the length is greater than equal to 2 will do this will be sufficient. So let us see how can we do that. So we can pick any 2 element and form a sequence of 2, form a arithmetic subsequence of 2 elements, and we can use the difference between these 2 elements as a criteria for extending this sequence. So just in case we are able to find another element, so that the difference between these and these 2 are matching the starting difference, then we can extend this array. So this problem, seeing the extension thing, we can see that this problem may be able to be solved by dynamic programming approach. So let us consider one state, and this state is I comma div. So basically this thing represent the number of arithmetic subsequences whose last element is a nums I, and it has got difference diff throughout the subsequence. So we can find this number of this dpi comma diff by summing all the dpj comma def plus 1, where where the def is numsci minus numsj. So basically, since the numsci minus numsj is def, we can add this numsci to the arithmetic subsequence ending at numsj to form the new subsequence. And this one is we are adding this one also because we can form another subsequence of difference diff by just using this nums I comma nums j, these two elements. That's why we are doing this. So we can do it for every j that is less than equal to I, and then we will have, after doing it over the array, we will have the computation values of all the dp I comma diff, and then we can add all these things to get the total number of subsequences, arithmetic subsequences of length greater than or equal to 2, and then we can subtract n into n minus 1 by 2 to get the final answer. So let us try to implement this. So first I will be storing the size of the nums array in integer n, and we will need a dp no, so we can't use a 2D matrix because the ranges of these numbers are of the order 10 to the power 9, and the differences are also of that order, so we can't use a dp array for calculating these things. So we are forced to use an unordered map, and for representing this state I am defining a hash, and I will call this key to be def into 2000 plus I. The reason why I am using 2000 because I is ranging from 1 to 1000, so multiplying it with 2000 will keep this key unique. So I will be mapping long int to long int, and we can call this to be subs count. Yeah, now we can start the for loop. So I'm starting from 1 because for I equal to 0 there won't be any case, because we cannot form a subsequence with only one element, and it will go up to n, and then we can have another loop for j that stands for every index less than I. Now we can calculate the def. So that is def is numsci minus numsj. So since numsci and numsj are integer, it may be possible that while subtracting them it will result into overflow of integer. So it will be better if we will convert them into long and then do the computation. Now we can form a key for this key, we can form a hash value for this key. So that will be, I will call it key current, and it will be def into 2000 plus I, and similarly the key for previous state will be key brave, and it will again def into 2000 plus j. Now we need to do this thing, and that is straightforward. We can do subs count, and it will be key current plus equal to subs count key previous plus 1. So basically this, after running these loops, these two loops, we will have all the like data for all these states, and now we can sum all of them to get the total number of subsequences. So for that I'm using an iterator. It will start from this count.begin, and it will go up to subscount.end, and we can add the count of each state to get the total number of subsequences. in the end we can do subtraction of the number of states consisting of number of subsequences consisting of only two elements. And since we were required to return the answer in the form of teaser, we can cast it in teaser. So the complexity of this whole program is like order of n into n, because this loop is order n, this loop is order n. So it's order n squared, and this is an order one operation. And like this can be at most order n squared. So basically this is order n squared algorithm. So seeing the constraint, it should pass the test cases. Let us try running it. Yeah, so we were using ll for representing long data type. So let us do this. So let us define it. Yeah, now this should work. So basically we need to use second for getting the point. Yeah, so we can submit it. So it got submitted.